what we have here now is a, we're going to make some videos using PiTape Corporation's NIST certified 4-meter tape measures, which I just received. We can take a look at the box here. PiTape Corporation, it's a container that it came in. Here's the tape measure. We'll look at that closer. It's a main tape measure, 4 meters, and there's a vernier that attaches to that tape measure to allow us to get to the 1/10 of a millimeter. As you can see here, the vernier caliper, and we can look at the blow it up a little here. The tape measure, as you can see, is marked in millimeters. Each one of those lines is a millimeter, and we're going to measure, of course, the hardwood circle that we initially measured before. Not that anything was wrong, we're just using now a certified NIST tape measure. So who is PiTape Corporation? They're an engineering tape measure company making tape measures for the space industry and other industries. They measure diameters and circumferences. The NIST is essentially the USA's Bureau of Standard Weights and Measures. So we're going to remeasure some of the previously measured circles that I've done before, their diameters and circumferences, to show the pi circumference of a 1-unit diameter circle. Like I said, these circles include a CNC machine cut circle and several circles cut on 1/2 inch thick foam board using a rotary circle cutter. First, the PiTape measure is a 4-meter tape measure marked in millimeters from the 3,000 to the 4,000 rule of hash marks. The first 3 meters are marked at each 1-meter mark from 0 to 3,000. We only need to see the details in the 3,000 to 4,000 millimeter range. So, as I showed you before, a vernier gauge allows us to measure to the nearest 1/10 of a millimeter, though we don't really need to get that far. As soon as we get out to the 4th digit, we know what the value of pi is. So these PiTapes that are certified will run you from several hundred to several $1,000s each. This one I'm showing you here from PiTape Corporation was around $400. The CNC machine that cut the hardwood circle all the way around here is a $100,000 Format 4 CNC machine made by Felder Group Incorporated. The adjustable 1-meter rotary cutter used to cut into, not all the way through, the foam board is made by NT Corporation. So let's look at our measurement of the diameter. I want to show you for each meter of the PiTape that it is accurate and that it is calibrated to itself as being accurate. So the first thing we're looking at here is the end of the tape. Let me blow it up here. At the 0 end, as you can see, it's right. You can see a pencil mark on the diamond right at the end of the circle. I'll show you the edge a little bit and come straight forward. And as we go across, the center, still on the diameter, we will come to the 1,000 millimeter mark, as you can see right there. We want to measure from the 1,000 millimeter mark, as you can see right here. Look at the bottom of the tape there on the edge, across the center, and over to the 2,000 millimeter mark. Bottom of the tape is on the edge, which is exactly what we expected. We're looking at the hash mark from the 2,000 millimeter mark, straight up and down over the edge, go across the diameter, to the 3,000 millimeter mark right on the edge there. Once again. So now let's measure the diameter of the wooden circle from the 3,000 millimeter mark to the 4,000 millimeter mark. Here's the one end of the beam compass, which points exactly at the 3,000 millimeter mark. And we'll pan over to the center of the tape measure at 3,500. That means the radius of the beam compass is 500 millimeters. And then let's pan over to the end of the 4,000 millimeter mark, which you can see is at the end of the diameter here. So we have 1 meter, 1 unit circle. So let's look at the tape measure from the other end, the 4,000 millimeter mark, and we see the pointer of the beam compass on there. On the edge. We go over to the middle to get the radius. Once again, the radius is at 3,500, so the radius at the 3,500 mark, the radius is 500 millimeters. And over to, of course, the beginning of this measurement at the 3,000 mark. Okay, so we have 1 meter diameter of the beam compass calibrated to that. Okay, now that we've measured the diameter with the pi tape measure, let's measure all the diameters using a beam compass. So we're set up here with a beam compass from the center of the circle to the edge. Let me see if I can zero in on this. And we will rotate the circle and track the beam compass. So here we go. Try to get straight up and down on the edge so that I'm not coming in from the side. Let's try to get it up and down, which we have with my handy dandy assistant here. And got enough light to see that the pointer is on the edge of the circle. Go all the way around, and we shall see that all the diameters are 1 meter. That is 1,000 millimeters. So there we go, all the way around, and that should do it. Here's our 1 unit diameter circle, 1 meter in diameter, 1,000 millimeters. The circle was cut by a Felding Group CNC machine. So we've wrapped our new 4 meter pi tape measure around the circumference of the circle, and we're going to measure the circumference here. So let's zero in and see what we can get here. Come around to the other side and take a look. We'll snug this up. As you can see, the measurement is 3,140, 1, 2, 3, 4, and looks like about a half, 0.5, 0.6 of a millimeter. So let's use our vernier caliper here and see if we can zero in on this a little better. I'll keep this lined up, and we see that it is, whoops, somewhere around, that's close to 0.5, 0.6, anywhere from 0.4 to 0.6 of a millimeter. We really only need to get to 3,144 to disprove old pi. So old pi would be somewhere around here, 3,141 and about half here. So you can see that's 3 millimeters off. True pi is longer than the old pi. Once again, we're about 0.5, 0.6 on the vernier.